This is part 2 of the Flexdrola case, and we'll begin with part C. Here, the underage and overage costs have changed from the earlier part of the problem thanks to the option that SelectChex has now offered us. The underage cost of an option is the change in profit if one additional option had been purchased that could be exercised. For example, if 700 options are purchased but demand is 701, then one additional option could have been purchased. The cost of obtaining the unit without the option is equal to $83.50. The cost of the option plus exercising it is equal to the $25 to purchase it plus the $50 to exercise it, so $75. So the purchasing the option would have saved the difference between these two, or $8.50. That's the underage cost for this problem. The overage cost on an option is the extra profit that could have been earned if the option were not purchased in the first place, assuming that it isn't needed. For example, if demand were $6.99 and the last option was not necessary. So the cost of purchasing that option, we have already said, was equal to $25. Computing then the critical ratio using these values is CU over CU plus CO, or 850 over 850 plus $25, which gets us a critical ratio probability of 0.2537. This falls between the z-values of negative 0.67 and negative 0.66 in the standard normal distribution function table. Using the roundup rule, we'll round up to negative 0.66. Then we can convert this to a quantity using the formula, the mean forecast plus the standard deviation times z, or 1,000 plus 600 times negative 0.66. This is equal to a profit maximizing order quantity of options of 604 units. With part D, we're going to evaluate some performance measures, and we've already solved for the z-value, which was equal to negative 0.66. So let's first figure out the expected number of units ordered beyond the purchased options, or expected lost sales. Expected lost sales are equal to the standard deviation times the loss. Using this z-value of negative 0.66 and looking it up in the standard normal loss table, we find that that equals a corresponding value of 0.8128. Multiplying that times the standard deviation, we get expected lost sales of 487.7. Then the expected number of options exercised, or the expected sales, will be equal to the mean demand minus the expected lost sales. Therefore, our expected sales are $512, or 512.3 units. Next, expected revenue is going to be equal to that forecast demand times the revenue per unit, or $121, for a total expected revenue of $121,000. Now we know profit is equal to revenue minus the costs. So let's take each of the costs individually. First, the cost of purchasing options. We know that we are going to purchase 604 at a cost of $25 each, for a cost of purchasing options of $15,100. Then the cost of exercising options, we're going to exercise 512.3, our expected sales, times $50 per exercise, and that's equal to 25,615. Finally, we need to account for the cost of the units purchased without options. So our lost sales are 487.7 times the cost of those units is $83.50 each, and that is a cost of $40,723. So then to compute the profit, we're going to take $121,000 less the $15,100, the $25,615, and the $40,723. And that results in an expected profit of $39,562.